2-6 combination of functions, composite functions, day 1. Your learning goal is that you will be able to build functions that model relationships between quantities from existing functions. Today, in this lesson, we're going to look at domain. And remember, domain are the x values that you can plug into a function that will keep it a real number. So the key to remember is our function has to be a real number. Usually our domain is going to be negative infinity to positive infinity, unless you see these two cases. These are cases when you will find a function to not be a real number. And those cases are division by 0, or taking the square root of a, or even an even root, I should say, of a negative number. So these are the two things that you have to watch out for that will cause your function to not be a real number. So I'll say non-real numbers. So if you see division or an even root, then you have to find those x values that you have to exclude that will cause your function to not be a real number. Okay, example 1, we're going to find the domain of each function. And remember the two things we're looking for. We're trying to keep our function to be a real number. So the two things we look for are division by 0 and square roots. If we don't see those, it's going to be negative infinity, positive infinity. So first up, our function x squared minus 7x. Do you see division? No. Do you see any square roots? No. So as long as you don't see that, your domain is negative infinity to positive infinity. That means you can use any number on the number line, plug it in for x, and this will still be a real number. Our second example, or example B. What have we here? Division. So we have to figure out what values of x would cause your denominator to be 0. In order to do that, you have to set your denominator equal to 0. Because right now, we don't know what those values are. And because there's an x squared, we're going to have to factor it. Factoring means we have to find two expressions. When you FOIL it out, you'll get x squared minus 2x minus 3. So I know I need an x and an x, because that'll make x squared. And then I need two numbers that multiply to give you negative 3. So that's multiplying. That will add to give you negative 2. And the only two numbers that will work would be 3 and 1, but the 3 has to be negative, the 1 is positive. And if you want to check, you can FOIL it out. So I'm going to set each one equal to 0. So we have x minus 3 or x plus 1. Okay, here x would be 3, or x could be negative 1. These numbers we have to exclude from our domain. That means on the number line, if we were going from negative infinity to positive infinity, here's 0, here's negative 1, here's 3. That means that we can use everything here not -1. Everything between, not 3. And everything greater. So this is how you write your domain. So we can do everything from negative infinity all the way up to -1, but not including. So that parentheses means not including. Then to represent the gap in between, then we can use everything from -1, not including, to 3, not including. So all those parentheses mean we can't use them. And then we got to join that union. That U means union. We're going to join the other side of our graph, which is from 3 to infinity. So that would be your domain when you're excluding two values. So everything to the left, everything in between, and everything larger. Example C. If you notice now, we have a square root or an even root, I should say. And even roots, you cannot take a even root of a negative number. So that means that we have to figure out what values of x we can plug in that have to be greater than or equal to 0, because that's what non-negative means. So we're going to take this part here, and we know we have to be greater than or equal to 0 because it has to be non-negative. Non-negative. So that's why we're doing that. All right, so we're going to get x by itself. So subtract the 12. So x has to be greater than or equal to -4. So to keep this from being a negative number under the radical, all of my x values have to be greater than or equal to -4. So on your number line, here's -4. And you see that equal sign? That means anything greater than or equal to. So your domain would be from -4, including, to infinity, positive infinity. Included. So that sign means included. And you can just try it out and see, because if you use anything smaller than -4, that's going to make this a negative number. And then D, our last example. Here we have division again. And we have to find out what values of x will make our denominator 0. So remember, we're going to set this equal to 0. And since there are 4 terms, we're going to factor by grouping. And we're going to find basically a GCF with our first group and a GCF with our second group. Okay, so the GCF of our first group is x squared. That's what they have in common. Greatest common factor is GCF. And you're going to take out an x squared, so that leaves x minus 2. The GCF of our second group is -9. And if I divide both of those by -9, I'm going to be left with x minus 2. You want there to be a common factor from both of your groups. So then when you write your factors, you're going to get the x minus 2, because that's what they had in common, and then x squared minus 9. And then you're going to set each one equal to 0. So I have x minus 2 equal to 0, or x squared minus 9 equal to 0. So here x could be 2, or I'm going to add the 9 over, square root both sides, and you're going to get plus or minus 3. So there are 3 numbers that I have to exclude from my domain. So I have negative 3, 2, or 3. We cannot use, cannot use, cannot use. So I'm shading everything we can. All right, so let's pause and finish. Our domain is going to be from negative infinity to negative 3, not including. Then remember, I got to put my union sign because that unites all of my intervals together. Then I have to go from negative 3 to 2. And all of these numbers are not included. Then I have to go from 2 to 3. And then I have one more interval. My last interval is from 3 to infinity. So that's how your domain will look if you have 3 numbers you had to exclude. So the more numbers you have to exclude, the more intervals you're going to see.